Alright, so in this video I'm going to be talking through pages 23 and 24 in the notes packet. This is where we are getting a little bit more in depth with inverse functions. So remember that for inverse functions, it's representing the same relationship, but going in the opposite order. So for example, in this example here, where we're starting with the number of bricks, trying to figure out the cost, we multiply by the cost of each brick. Whereas if we start with the budget and we want to go backwards to the number of bricks, well, then we take the number of bricks and divide by the cost of the budget. So notice how those are kind of opposite operations, right? Multiplication versus division. And that actually goes for any inverse function. So for example, if we have this function, f of x is equal to x squared, well, then the inverse function is the opposite of that. What's the opposite of squaring something? Well, it's taking the square root. So, for example, here we have f of 4, that brings us to 6. And if we take the inverse of that, we know if we input 16, we gotta go back to 4, right? That's kind of what it means to switch the domain in the range, is that when we input 4 into our original function, output 16, that means when we input 16 into the inverse function, we must go backwards to 4, right? And that's kind of what we saw here. In the normal function, if we go 4 to 5, then in the inverse function, we have to go 5 to 4. And so this is a really important point, that any point AB on f of x has to be mirrored by point BA on the inverse function, right? If we input A to output B in our function, then in our inverse, we have to input B to output A, right? It has to go the other way. So this, we know that with our normal functions, right, we input x and we output y. So if we know that we can flip them, well then how you find the equation for an inverse function is doing exactly that, right, switching your x and y around. So I'm going to start, we have this function here, f of x is equal to 3x squared minus 2. The first thing we're going to do is just change that to be y is equal to 3x squared minus 2. This is not necessary. If you are comfortable switching x and f of x, you can just do that too. But I think most people are more comfortable doing algebra with x and y and thinking about x as an input and y as an output, so we're going to kind of work with the notation that is most comfortable to us. And now, to find the inverse, we know that any input x that outputs y in our original function, well, that means in our inverse function, if we input x, we have to output y. So we're going to switch x and y there. And now this function is in terms of x, but we know x is our input, so that's not super helpful. So now we need to rearrange this to be in terms of y, and then that will be our inverse function. So if we think about rearranging this, we have x is equal to 3y squared minus 2. Right, we want to get this y alone. So we're going to start to do inverse operations to move things across, right? Flashback to algebra 1. So we're going to add 2 there. It's going to be x plus 2 is equal to 3y squared. Then we need to divide both sides by 3. I'm going to write this x over 3 plus 2 over 3 is equal to y squared. And that means, you know what, let's leave it as one fraction, actually. Let's leave it like this. And then finally, we're going to take the square root of both sides, and that means that y is going to be equal to the square root of x plus 2 over 3. And that is kind of a crazy-looking function. But if we think about why that works, let's try and think about what would f of 1 be. Right, so f of 1 would be 3 times 1 squared minus 2. So f of 1 would be 1. And that means that f negative 1, the inverse function, so we want to put back the f of x, we want it to now be f negative 1 of x. So this is what we just solved for to be the inverse function, square root of x plus 2 plus 3. And so going back to what I was saying, right, in our original function, when we inputted 1, we outputted 1. that means in the inverse function that also needs to be true. So f negative 1 of 1 is the square root of 1 plus 2 over 3. That's the square root of 3 over 3, which is the square root of 1, or 1. And that will work for any value. If you choose an input in the original function and get an output, if you plug that output into the inverse function, you're going to get back to the original input. Then there are kind of 4 examples down here. So I'll go through that process that we just did there. So y is equal to 3x minus 2. Then we need to switch x and y. So that means x is equal to 3y minus 2. Add 2 to both sides. And I get x plus 2 is equal to 3y. Or y is equal to 1/3 x plus 2 over 3 if we divide everything by 3. Right, imagine dividing this by 3, dividing this by 3, and dividing that by 3. All right, and we have g of x is equal to square root of x plus 4. That means y is equal to the square root of x plus 4. That means x is equal to the square root of y plus 4, right? We have to switch x and y to find our inverse. And I'm going to rewrite this just for notational sake. F negative 1 of x is equal to 1/3 x plus 2 over 3. Okay, back to this one. So now if we want to undo that square root, we're going to square both sides. That means x squared is equal to y plus 4. That means y is equal to x squared minus 4. If we subtract 4 from both sides, and that means, g negative 1 of x is equal to x squared minus 4. All right. Now down here we have h of x. So let's do y is equal to 8 of x cubed. That's our original function. And that means if we want to find the inverse function, we have to figure out, well, x is equal to 8 times y cubed. And then we need to solve that for y. And so I'm going to start by dividing 8 on both sides. You get x over 8 is equal to y cubed. We can take the cube root of both sides. The cube root of x over 8 is equal to y. You can leave that like that. But I'm going to say we can rewrite this to say y is equal to the cube root of x over the cube root of 8, which means y is equal to the cube root of x over 2. Right? And that means that our inverse function, h negative 1 of x, has to be equal to the cube root of x over 2. All right. And then this one is a little bit tricky. Because so we start with y is equal to 5 plus 5 over x. When we switch x and y to start to find our inverse, that means x is equal to 5 plus 5 over y. And now we need to try and solve for y. And this is a little tricky because y is in the denominator. So I think the easiest way to do this is we're going to subtract 5 from both sides. You get x minus 5 is equal to 5 over y, right? Subtracting 5. Now I'm going to multiply both sides by y to get y out of the denominator. So I now have y times x minus 5 is equal to 5. And now I'm just going to divide both sides by this whole expression here, x minus 5. Meaning that my new expression would be y is equal to 5 over x minus 5, meaning that the inverse, if k of x is 5 plus 5 over x, then k negative 1 of x is 5 over x minus 5. Okay. Moving on to page 24. So now we're going to think about this visually. So we're going to start with the function f of x, because it's actually a lot easier, I think, to find the inverse functions visually than it is algebraically, and I'll show you what I mean by that. So let's start by just plotting the regular function here. So So it's defined at these points. It's -3, -1, -2, 2, -1, 1, and then 1, 3. So it's defined at those 4 points there. Now let's think about what would the inverse of this look like. Well, we know to find the inverse, we swap the domain and range. So that means now when x is -1, y has to be -3. And now when x is 1, y has to be -1. Now when x is when x is 2, y has to be -2. When x is 3, y has to be 1. Right, just noting I'm reversing the direction there. So -3 went to -1, so now -1 goes to 3. -2 goes to 2, so now 2 goes to -2. -1 goes to 1, so now 1 goes to -1. And 1 went to 3, so now 3 goes to 1. Right, just reversing that mapping. And now let's see what that looks like when I graph it. So I would go -1, -3, 1, -1, 2, -2, and then 3, 1. Now let's look at these two graphs here. This is the one on this is our regular function. Here's our inverse function. What relationship do we see here? So take a moment, pause the video, think about that. What relationship do you see here? And then I'll tell you in a minute. So what happens is if you want to go from your original function to your inverse function, you're going to take all of the points and you're going to reflect them across this line. And see how if we reflect this set of points across that line, we're going to end up with this set of points over here. Let me actually, so I'll graph the inverse ones in red right on here to show you this. So we have 1, -1, -3, 1, -1, 2, -2, and then 3, 1 right there. So you can see that each of these is directly mirrored over the line, over this line here. And that's the line y equals x, right? It's a line through the origin with a slope of 1. So it goes like that and like that. And that's actually how you can find the inverse of any function graphically, right? So it makes sense that if you would swap x and y to do it algebraically, that graphically you reflect over the line y equals x. So let's see what that looks like for these two functions down here. So I'm going to draw the line y equals x in like this. I'm going to draw the inverse function by kind of mirroring this over the line y equals x. So the inverse, it doesn't have to be perfect, is going to look something like that. And then for this one over here, the inverse is going to look something along the lines of that, right? Mirrored over the line y equals x.